Hello students, I am Madhukar Supreme, Assistant Professor in Chemistry, Vijayanagara College, Hospet, belongs to B.Sc. University, Ballari. Now you have to learn this 6.2 EMF for the B.Sc. 6th sem is concerned. Part 5 we are studying now. Under this part 5 we are studying some problems in the examination for 1 mark. The problems are very simple. Just try to remember the formula to calculate the electrode potentials. So the first problem is electrode potentials are standard reduction potentials of zinc Zn bar Zn2 plus and Cu bar Cu2 plus electrodes are minus 0.76 volts and 0.34 volts respectively. Calculate the EMF, or sometimes in the examination they will ask this standard EMF of the cell constructed with them. Then you try the solution. Given E0 Zn bar Zn2 plus standard reduction potential is given for zinc, it is minus 0.76 volts. Another given value is for the copper E0 Cu bar Cu2 plus is plus 0.34 volts. You have to calculate the standard EMF for the another symbol for this is E0 cell. Try to write the representation of this cell. In this thing you have to remember, very important thing you have to remember in this is among these two, which is having the higher value of take it as cathode, which is having the lower value of take it as anode. Cell representation, if want you can write in the examination, otherwise it is not necessary. But representation of the cell is Zn bar Zn2 plus double bar, that is alternate Cu2 plus bar Cu. So this left side portion is called anode. This left side portion, right side portion is called cathode. The standard EMF is equal to E0 cell is equal to, the formula is E cathode minus E anode. So I told that E cathode is having the higher value, E anode is having the lower value. Subtract these two by taking the values 0.34 volts. This is minus this is 0.76 volts. After simplification you will get plus 1.10 volts. Another important thing you have to remember in this case is this E0 cell should be always a positive. That means this reaction, this process is feasible. You must get the answer in the form of a positive quantity only. Then only your answer is correct in the examination. Second, standard reduction potentials of zinc bar Zn2 plus and Fe2 plus bar Fe3 plus, that is ferrous and ferric. In the presence of this inert electrode platinum, electrodes are minus 0.76 volts and plus 0.77 volt respectively. Calculate the standard EMF of the cell constructed with them. Write the given quantities. E0 Zn bar Zn2 plus minus 0.76 volts. Previous problem is also in the same like. Here E0 Fe2 plus bar Fe3 plus. Ferrous versus this ferric value 0.77 volts. You have to calculate the E0 cell or standard EMF. The representation of this cell is Zn bar Zn2 plus acting as the anode. This is left side. Double bar Fe2 plus bar Fe3 plus is platinum. This is cathode. This is right side. So formula standard EMF E0 cell is equal to E0 cathode minus E0 anode. Or you can write this as in another way also E0 right minus E0 left. So right is this one 0.77 volts. This is minus left is minus 0.76 volts. After simplification you will get this again a positive quantity plus 1.53 volts. It indicates that this is also feasible. Third one, calculate standard EMF of the cell cadmium Cd bar Cd plus that is plus 2 double bar Cu plus bar Cu, cadmium in the copper combination. Given E0 cadmium with this cadmium 2 plus is equal to minus 0.40 volts. E0 copper 2 plus with copper is plus 0.34 volts. Value is again same. Try to write that cell representation. Cd bar Cd2 plus double bar Cu plus 2 single bar. So this is cell representation. And this is left side, this is right side. And this is anode and this is cathode. So standard EMF E0 cell is equal to E0 cathode is cathode minus E0 anode. Cathode value is 0.34 volts minus 0.40. Again after simplification we will get plus 0.74 volts. It indicates that the positive quantity of this standard EMF is indicated that this state is also feasible. So in all the cases, this phi naught cell should be a positive quantity only. In the examination, we will get the 4 marks question. How to measure the EMF using potentiometer? That is measurement of EMF using potentiometer. Some drawbacks are there. Drawbacks of measuring EMF using voltmeter. Actually, to measure this EMF, voltmeter is sufficient. But in this case, voltmeter is not required. Voltmeter is not giving the exact value. So we are using the potentiometer because of these 2 drawbacks. The first one, chemical reaction occurs in the cell and some current is used during the measurement of the voltage, and this alters the actual EMF. The first one. Second drawback is when current flows, a small portion of EMF is used to overcome the internal resistance of the cell. So for these 2 reasons, voltmeter is not used to measure EMF, but this small current can be accurately measured by using the potentiometer. The principle using in this determination is Poigendorf's compensation principle. So this principle is used in the potentiometric method for the accurate measurement of EMF. Here the unknown EMF is opposed by another known EMF until the 2 are equal. This is the setup. So in this case, this wire AB is there. This is of 1 meter long, and this AB is having the 2 sides connection. One is cell, that is battery. This battery is connected to the rheostat. In this case, this is connected to the first one. S means standard cell having this known EMF, and X is called the another cell into the unknown EMF. You have to calculate the unknown EMF of this X, and these 2 are connected to the galvanometer through this key. So this is explained here. It consists of a wire AB with this wire AB, which is about 1 meter long. With this 1 meter long, the 2 ends of this wire are connected to the working battery C. A standard cell S, that is cell of known EMF, is connected to the end A. At the other end, the cell S is connected to a galvanometer G through a key K. This is the key K and then galvanometer. The galvanometer is then joined to a sliding contact. This is joined to the sliding contact here. Sliding contact that moves on the wire AB. The cell X means cell of unknown EMF is similarly connected to the key K. This X is also connected to the key K. The galvanometer, next is galvanometer, and then sliding contact. This is also connected to the sliding contact. By using key K, the cell S is put into the circuit. First S is put into the circuit, and the contact is moved to and fro. This sliding contact is moved to and fro like this along AB. When no current flows, there is no deflection in G. If there is no deflection, G means there is no current flows. The point of contact X1, this is contact X1, is recorded. This X1 is recorded. Then by using the key K, the cell X is put into the circuit. This is removed and this is taken into consideration, put into the circuit, and the procedure is repeated to find the corresponding point X2. That is to get no current flows or no deflection of G. Then the EMF of the cell X is calculated by using the following equation. Unknown EMF is equal to Ex. This is proportional to length of AX2, and the known EMF or standard cell EMF is equal to Es proportional to length of AX1. Then the ratio Ex divided by Es is equal to, if this proportional sign is removed, you will get one constant. If this is also removed, you will get another constant. These 2 constants are same, so get cancelled. So Ex is equal to length of AX2 divided by length of AX1. Length of AX2 is this one, length of AX1 is this one. Therefore Ex is equal to, Ex means unknown EMF is equal to known EMF into length of AX2 divided by length of AX1. Hence, by knowing the standard cell EMF Es, length of AX2 and length of AX1, the EMF of the unknown cell can be determined. In the examination, you will get the question usually for 4 marks. Okay, I think you followed this one. Thank you.